Hey class, I am going through your review that's for your tests, test 4. Okay, so let's start. If an event cannot occur, its probability is 0. If an event is certain to occur, its probability is 1. The collection of all possible outcomes of a probability experiment is called a sample space. Okay, given two events, A and B, what is the additive rule? Additive rule is probability of A plus probability of B minus the probability of the overlap, A and B. Okay, given two events, A and B, what is the multiplicative rule? Probability of A and B is probability of A times probability of B given that A has occurred. Given event A, the event that A does not occur is called the complement. Two events are blank if the occurrence of one does not affect the probability the other event occurs. It's called independent. Two events are independent if the occurrence of one event does not affect the probability of the other. Two events are blank if the occurrence of one excludes the probability of the other. Well, that would be mutually exclusive. The sum of all probabilities in a discrete probability distribution must be equal to 1. A continuous random variable can take on any value in an interval. The numerical outcome of a probability experiment is called a random variable. Okay. Which of the three represents a distribution of these a probability distribution table? Why and why not? So probability distribution tables, the probability of each individual variable x must be either equal to 0 or greater than 0 or less than or equal to 1. So it has to be between 0 and 1 inclusively. And then the sum of all the probabilities have to add up to 1. So each individual probability has to be between 0 and 1 inclusively, and the sum of all the probabilities have to add to 1. So the first table fails for various reasons, but for the big one here, it fails because of this. You can't have a probability of 1.2. The next table, each individual probabilities are fine. Each individual probabilities are fine. None of them are less than 0. None of them are greater than 1. So let's just see if they sum to 1 then. So that's the only thing that might fail. So this is 0.4. 0.4 plus 0.3 is 0.7. Plus 0.05 is 0.75. Plus 2 is 0.95. Plus additional 5% is 100%. So this adds to 1. So this guy checks. This is a probability distribution table. The next one, it fails for various different reasons. One, the sum doesn't add up to 1, but it also fails because of this, because it has a negative probability, which doesn't exist. Okay, next question. A school audit of algebra class shows that 1,000 students, 150 got A's, 250 got B's. I think something didn't print out in this. Let's say 100 got C's. Let's put that in there. And the rest got D's and F's. What's the probability of a student getting an A? Well, that would be 150 over 1,000, which is 15%. Okay, what's probably they got an A or a B? Well, that would be 150 plus 250, which is 400. So 400 out of 1,000, which is 40%. Okay, and then what's probably that you got D's or F's? They don't ask for that, but you would use the complement rule. So A's plus B's plus C's is 500. So the rest got D's and F's. So that would then be 500 over 1,000 using the complement rule. Okay, now here we have a probability distribution. Well, no, that's just a table. Okay, we have a table. And this is just a distribution table. It doesn't have probabilities attached. And they want us to figure out various different questions, probabilities. So using this table, answer the following questions. Find the probability the random selected student drove. Well, 20 students drove out of a total of 30. So that would be 20 out of 30, which is 2/3, which is 0.666, etc. Okay, although you can leave these as fractions. You don't have to do it as decimals if you don't want to. Find the probability a random selected student drove or flew. Drove or flew. So 9 people flew, 20 people drove, but then we have 5 people that did both, so we have to subtract that. So this would be 20 plus 9 minus 5, which would be 24 out of 30. Okay. So you have to use the rule above. So here's people that drove, here's the people that flew, and here's the overlap. We can't double count the overlap. Okay, given a student did not fly, what is the probability the student drove? So now we're looking at filtering, we're zooming in on particular rows and columns. So we're on the no fly column. So we're saying, given that a student did not fly, so now this column is the only column that exists. So in this column, what's probably a student drove? Well, 15 out of 21. This isn't out of the total because it says given. Anytime you see the word given, you're restricting your view to certain rows or columns. Okay. Next one is given the student drove. What is probably they also flew? So now we're at the drove. So now we are in the drove row. That's the only thing that exists. So then it asks the question, if a student drove, what is the probability that they flew as well? Well, that would be 5 out of 20. Okay. Okay. Individual plays on a slot machine are independent. The probability of winning on any play is 35%. What's the probability of winning 4 plays in a row? Well, if they're independent, then we just multiply 0.35, 0.35, 0.35 times 0.35, which is 0.35 to the 4th power, which is an extremely small number. Let me see. 0.35 raised to the 4th power is 0.015. Okay. What is the probability of losing once in 4 plays? The probability of losing once in 4 plays is 1 minus the probability of, oh wait, no, let's not use the complement rule on this. So probability of losing once in 4 plays. Okay, so that means it's 4 times probability of losing once, which is 0.65 times probably winning the rest, the other 3, like this. So it equals 4 times 0.65 times 0.35 to the third. Now, why it's 4 is there's 4 different ways of ranging losing. So here, we could lose the first round and then win the next 3. Or we could win the first round, lose the second round, and then win the next 2. Or we could win the first 2 rounds, then lose, and then win the last round. Or we could lose the first 3 and then, or win the first 3 and lose the last round. So there's 4 different ways of distributing one loss over 4 spots. And that's how come we multiply it by 4. Each one of them has the same probability of occurring, whether you lose first or second or third or fourth. They're all 0.65 times 0.35 to the third power. So then we got to plug this in to a calculator. Just a minute, I'm in trouble with my calculator. 4 times 0.35 times 0.35 times 0.35 times 0.65. So this would be 0.111. Okay. Suppose a slot machine is played 5 times in a row, was probably winning at least once. So here's where we're going to use the complement rule. So the probability of winning at least once is 1 minus the probability of never winning. Okay. So that is 1 minus 0.65 to the 5th power. Okay, so we're going to go going to be, when you do this, it'll be 0.884 approximately. So the probability of winning at least once is 1 minus the probability of never winning. That occurs when you lose every single hand, never winning. So that's 0.65 to the 5th power. Okay. Next one. 23 cars enter Indianapolis 500 held at Indianapolis Speedway in Speedway, Indiana. How many groups can be formed by winning 1, 2, and 3rd place? So this is, so we have 23 people racing. And then we're selecting 3 spots where order matters. And this is selection without replacement. So when you have selection without replacement, where order matters, this is permutation. So we're doing 23 P3. Okay, and I'll enter that into a calculator. And we get 10,626 different ways of winning first, second, and 3rd place. Okay. Next question. After a statistics exam, you decide to treat yourself to double scoop ice cream cone. You enter the store to find there are a few people in front of you, so while you're waiting, you happen to notice there are 12 flavors to choose from. A little boy in front of you stands on his tippy toes trying to see all the different flavors and says, I wonder how many ways I could order a double ice cream sundae. You remember you have your graphing calculator in your coat. So you figure this out. Assume that order does not matter without replacement. So if order doesn't matter without replacement, that's combination. So we have 12 flavors combined where we're choosing 2. That's 12C2. I plug that into calculator. And you have, just a minute, guys, 12. You end up with 66. So there's 66 different ice cream cones you can make where order doesn't matter without replacement, where you can't reuse a flavor and the order that they're selected doesn't matter. Okay, next question. A student council has a certain school has 12 members. 5 members will form an executive committee consisting of president, vice president, secretary, treasurer, event planner. And how many ways can these 5 positions be filled if it matters who gets the position? So that would be 12P5. Okay, because order matters and it's without replacement. So it's 12. So that's 95,040. Okay. Now, how many ways can 5 people be chosen for the executive committee if it doesn't matter? So now we're doing combination. So this is now 12C5. Okay. And we get 792. Okay, 792 different ways where you can form a committee of 5 people from 12. Okay, next question. An advanced placement tests are graded on a scale of 1 through 5. The College Board reported the distribution scores on the AP test. So this is a probability distribution table, are as following. So 38% score 1, 30% 2, 12% 3, 15% 4, and 5% 5. What's probably a random selected student is 3 or higher? Well, that's going to be the 12% plus the 15% plus the 5%, which is 32%. Find the mean of the distribution. Well, the mean is you're going to take and multiply these together and then add them together. Okay, so 0.38, let's see. And we get 2.19. So that is the mean. Standard deviation, if you're going to do this by hand, you're going to have to, here, I'll do it by hand over here. You're going to have to go create a table like so. So we're going to subtract 1 minus 2.9. It's going to be negative 1.19. Then 2 minus 2.9, that is negative 0.19. 3 minus 0.9, which is positive 80.81. 4 minus 0.29, which is 1.81. 5, which is through 5, which is 2.81. Okay, so I took the values, the x's, I subtracted the means. Now I need to multiply these by their probabilities. So the probabilities for this is 0.38, 0.30, 0.12, 0.15, 0.05. So now but I'm gonna have to square them first. So I have to square each one of these now. Okay, then I multiply by the probabilities, and then I sum them, and then I take the square root. So I've now squared them all and then multiplied them all by the probabilities. Now I need to sum them up. So I need 0.538118 plus 0.01083 plus 0.078732 plus 0.491415 plus 0.344805. When we do that, we get 1.506962, and then we square root it. And we get 1.228. So then the standard deviation is 1.228. Now, that's doing it by hand. So how I did it by hand again is I took individual x values, I subtracted the mean of 2.19. That gave me these values here in yellow. Then I squared those values, which is what I did here, and then took the square, multiplied by the probabilities. That then gave me this here. Then I summed it, and then I took the square root. And that gave me the standard deviation. Now you could enter x and p of x into lists, and list 1 and list 2 in your graphing calculator, and then do one var stats on it, and you will get the same answer. Okay, next question. So we have probability of A is 7%, probability of B, or 70%, probability of B given A is 0.35. Find probability of A and B. Well, probability of A and B is probability of A times probability of B given that A's occurred, which is just 0.7 times 0.35. Which is 0.245. Okay. Are A and B mutually exclusive? A and B are only mutually exclusive if probability of A and B equals 0. So if probability of A and B equals 0, then it's mutually exclusive. This is not true, so they're not mutually exclusive. Okay. Are they independent? They're independent if probability of B, independence is probability of B equals probability of B given A. So does 0.35 equal 0.35? The answer is yes. then they are. So yes, they are independent. Okay, next question. Find the individual probabilities, okay, given that the probability of A is 60%, probability of A and B is 30%, probability of B complement is 60%. So we're going to do a Venn diagram here. So we have probability of A and B, okay, and we need to fill it out. So probability of A and B is 30%. So that right there is 30%. We got that from this here. Okay, then we have probability of A is 60%. Well, that's all of A, including A and B. So all of A is 60%, which means this part of A is 30%, because the two 30% add to 60%. Okay, now we have probability B complement, which is everything outside of B is 60%. So that means both this region and this region has to add to 60%, because those are both regions outside of B. Therefore, this also has to be 30%, because the two green regions have to add to the 60% because of this rule here. Okay, then the only region left to fill out is the probably B that's not also in A. And all the probabilities have to sum up to 100%. So that leaves this with just 10%. Okay. Because 30 plus 30 plus 30 plus 10 is 100%. So what's the probability of B? So this is A. Probability of B is, I'm going to highlight it, are those two added together. So that's 40%. B, we just answered with the Venn diagram. And then what's probably of A or B? Well, probably A or B is this region here. That's A or B. And that's 30 plus 30 plus 10, which is 70%. Okay? That's how you do that problem. The next one is your neighbor has told you that he has a raffle going with 3 prizes. A $400 prize, a $200 prize, and a $100 prize. Each ticket costs $5, and there's 1,000 tickets to be purchased. What is expected value of a ticket? Well, okay, we have first place, second place, third place, and everybody else. Okay, so here's your X's, that's your what you get, and here's your probabilities. So if you win first place, you think you get $400, but you actually only get $395 because you paid $5 for the ticket. So your winning is $395. If you win second place, you don't win $200, you win $195 because you get your $5 back. So your prize is $195. Third place is $100, which means your prize is $95. And then if you don't win those first, second, or third, then you just lose your $5. Now we have probabilities. What's the probability of winning first place? Well, that's 1 out of 1,000. What about second place? There's also 1 out of 1,000. Third place, 1 out of 1,000. And then not winning at all, that's 997 out of 1,000. Then we have to multiply the X's by the probability. So we go 395 times 1 out of 1,000, which is 0.395, plus 0.195, which is 195, and then plus 0.095. And then the last one is negative 5. 5 times 9. 5 times 997 divided by 1,000. That's negative 4985. So that's negative 4985. So now we just add them all together and you get your answer. So 0.395 plus 0.195 plus 0.095 minus 4.985, and we get negative 4.3. And that is your expected value. So again, how you find your expected value is you multiply the prize by the probabilities on each of them and then sum them, and that'll give you the expected value. Okay, next is we need to solve this binomial expansion problem by using the binomial theorem. Okay, and what we have here is binomial theorem. So it's a plus b to the nth equals n a n plus n minus 1 a n minus 1 times b plus all the way down to n1 a1 b n minus 1 plus n0 b to the nth. Okay, we covered this formula in class. Remember, these right here are combinations. So let's do this. A is going to be 2x, and then b is going to be 3, and then n is 5. So let's write out this formula. Okay, so it's going to be 5 to the 5. So it's 5c5. A, which is 2 to the x, 2 to the x to the 5th, plus 5, 4, 2 to the x to the 4th, and then b to the 1st, which is 3 to the 1st, plus 5, 3, 2 to the x to the 3rd, 3 to the 2nd, plus, I'm going to wrap around here, plus 5, 2, 2x to the 2nd, 3 to the 3rd, plus 5, c1, 2x to the times 3 to the 4th, plus 5c0, 3 to the 5th. Okay, so that's the formula, using the formula here. Now, I need to figure out what all the combinations are. So here's all the combinations. I highlighted all of them. Okay, and they are in your calculator. So this right here is 5c5, which equals 1. This one here is 5c4, which equals 5. This one here is 5c3, which equals 10. This is 5c2, which also equals 10. This is 5c1, which equals 5. This is 5c0, which equals 1. Okay, so I have all those. I'll put them in. So then we have 2 to the x to the 5th plus 5 times 2 to the x to the 4th times 3 plus 10 times 2 to the x cubed times 3 to the 2nd plus wrap around 10 2x second 3 cubed plus 5 2x 3 4, and then plus 3 to the 5th. All right, so now got to start doing this. So let's look at the first one, this 2x to the 5th. Well, that's 2 to the 5th, which is 32, and then x to the 5th. So this is 32x to the 5th. Next one, this right here, that's 16x fourth times 15. So then we got a calculator, go 15 times 16, that's 240. So that's going to be plus 240 x to the fourth. Next, we come here, 2x cubed, that's 8x cubed. 3 to the second is 9. So it's 8 times 90, which is 720. So this would be 720 x cubed. Now, next row, that 2x squared is 4x squared. 3 to the third is 27 times 10. So that's 40 times 27, which is 1080. So that's 1080 x squared. And then plus, next one is 81 times 10, which is 810 x. And then last one is 3 to the fifth, which is 243, if I remember right. Let's see. Yep, it is 243, and that'll be my answer. Okay? And that's how you do it. So you follow the formula, plug things in, work it out. And that's your exam. I hope you have a good time studying. Talk to you later. Bye.